So in this chapter, we're going to look at polynomial functions. Poly meaning many and nomial meaning numbers. So we're looking at functions that have many numbers inside of them. The first vocabulary term is end behavior, which is exactly how it sounds. What is the end behavior of my graph? Where is it going on the left towards negative infinity? Where is it going on the right towards positive infinity? As you see here, we have different kinds. A graph that goes up on both directions, down in both directions. On the left could be going down, on the right could be going up, and vice versa. So take this polynomial here, x times x minus 1 times x plus 3, and we want to decide what is the end behavior. Where is it going towards negative infinity? Well, simply, without just looking at the numbers here and knowing what it is, the best option would be to graph it and see where it's going. So as you see here on the left, towards negative infinity, I'm going down. And on the right, going towards positive infinity, my graph is going up. That is how we're going to find end behavior. Now this chart here shows different patterns. Notice if I'm looking at my leading coefficient, if that number is even and positive, well, both are going up. If it's odd and positive, well, the left is going down, the right is going up, vice versa, whatever. Basically, I say just graph it and then look at the graph and see which way they're going on the ends. Probably one of the most important vocabulary terms with polynomials is the term zeros. Now, zeros is basically finding the x-intercepts of the graph. So one way to find the zeros is to graph it and look at the x-intercepts. In this case, I see I have zeros at -3, 0, and 1. If I were to look at the function itself, x times x minus 1 times x plus 3, to find the zeros algebraically, I want to look at each of these separate. Look at the x, look what's in the parentheses x minus 1, and look at the parentheses x plus 3. What does it take for each of those to equal 0? For x, of course, how do you make x equal 0? Well, x equals 0. Plain and simple. What about x minus 1? What do I plug in for x to make it equal 0? Well, what's the opposite of minus 1? Plus 1. So 1 minus 1 is also 0. So 1 is a 0. And what do I plug in for x plus 3 to make this whole thing inside the parentheses equal 0? Well, what's the opposite of plus 3? A minus 3. -3 plus 3 equals 0. So my zeros here, doing this algebraically, is 0, 1, and -3. Let's look at this other function. 8x times x minus 1 squared times x plus 3 cubed. Again, one way you could do this is to graph this function and look for your x-intercepts, but we'll do this algebraically. What does it take for me to get 8x and make that equal 0? What do I plug in for x? Well, 0 times any number is 0. So if I plug in 0 for x, that 0 will become 0. Now let's look at x minus 1 squared. What would make that 0? Well, what's the opposite of minus 1? Well, that is a plus 1. 1 minus 1 will make that part of the polynomial 0. And look at the other, x plus 3 cubed. What would make that 0? Opposite of plus 3 is a minus 3. -3 plus 3 is 0. So my zeros are 0, 1, and -3 here with this function. Now let's look at the powers. Look how I have an x minus 1 squared and an x plus 3 cubed. Do those powers mean anything? Well, that's where we get the term multiplicities. So yes, they are very important because I can rewrite this function 8x times x minus 1 squared times x plus 3 cubed as 8x times x minus 1 times x minus 1 times x plus 3 times x plus 3 times x plus 3. So as we see here, I don't just run into 1 as being a 0 once, I run into it twice. Also at -3, I don't run into -3 once, I run into it 3 times, as -3 will fit into each of these parentheses. So multiplicity is how many times do you have that as a 0? And you can just basically look at the power to figure that out. So here, my zeros are 0 with a multiplicity of 1 because it's raised by a power of 1. 1 with the multiplicity of 2 because that x minus 1 in parentheses is raised to square. And -3 with the multiplicity of 3 because x plus 3 is being cubed. So when you find zeros, look to what makes each of these 0, or you can look for your x-intercepts, and then figure out how many of those zeros you have. That will be your multiplicities.